Hey, look, I had to time that just right. Let me click this off. Yep, I don't want to leave the meeting. Okay, cool. So again, thank you for having me here today. I do like to talk. I do like to speak. I like to give back. And today we are going to talk about saving yourself as a DBA with accelerated database recovery in SQL Server 2019 and 2022. My contact information is on the slide before you. I am a principal consultant with Denny Chair & Associates. My email address is there. You're welcome to email me anything about the presentation, or even if you got SQL Server questions, you just want to chat, I'm happy to converse back and forth. My LinkedIn is on there. You can feel free to connect. I'm on Twitter. That's about the only social media I do. I kind of nixed Facebook and most of them some time ago. I am on Twitter as SQL R Us. That's not SQL Russ. Think Toys R Us. I dabble in just about every facet of SQL Server, except as Chad mentioned, I do not like ADF. Give me good old fashioned SSIS. I'm good. ADF infuriates the fire out of me. So I don't do BI stuff. I don't write reports. Don't make me ask them to write reports or build cubes. That's not what I do. The pandemic kind of nixed my blogging for a while. I'm trying to get back into it, but I do blog at SQLRS.com. I am heavily involved in the community. If you don't know who Denny Chair & Associates is, Chad mentioned us, but we are a small boutique of SQL Server nerds. We like to solve business problems with SQL Server and data. If you are looking for a consultant to come in and help, look us up. Give us a holler. We'd love to talk to you. Here's a quick agenda that we're going to talk about. We're going to talk about what is ADR, why do we care, what the old school method is, what the new hotness is, and how it functions. And then I've got a pretty in-depth demo. You may or may not see the debugger come out, so we might debug some code in SQL Server, but I'm going to show you how ADR actually works underneath the hood. And then we'll have time, hopefully, with questions and answers. We're a pretty small group, so feel free to unmute, ask questions. I'll try to monitor the chat, but easier to just unmute, ask me questions, and we can kind of go from there. So with that, why do we even care about this massive improvement that Microsoft did with 2019, SQL Server 2019, and why do we even care? If we were in person, this is probably where I would ask, who here has executed a long-range transaction? It's been running for 24 hours, whatever, or a developer has, and then suddenly somebody kills it. And then we as DBAs or data professionals are sitting there waiting for this thing to roll back. With the nature of the old way that happened, anything that's not ADR enabled, we've all been there where we've had to wait for, and I've done it myself. I've executed a long transaction, gone to lunch, forgot about it, thought I had killed it or canceled it or had finished. And then we had to roll it back and we're waiting there and we're still waiting there. We've all heard those horror stories, even online or in person of 24 hours, 48 hours, and they killed it. And they're like, what do we do? We tried rebooting the server, and rebooting the server even makes it worse because it takes the whole database offline, not just that individual transaction. So we're going to talk about, actually, I'm going to show you why ADR really can save you as a DBA from getting into the state where you're constantly waiting for that transaction to finish. And without fail, when you're waiting for that transaction to finish, you've got some CEO, some C-level person behind you going, how long is it going to take? And we all know that answer, right? If your query's been running for 24 hours, it's going to take about 24 hours for it to roll back, usually, give or take. So ADR will help you save you from that scenario. If you really can't sleep at night, there's actually a really good white paper. It's called the Constant Time Recovery in Azure SQL Database. That bit.ly link will take you to it. It's about 7 or 8 pages, 9 pages long, I think. But I found it very, very in-depth, and it talks about how it functions down on paper. I actually read it several times before it all kind of clicked in my head. And then I was like, oh, I want to go see this stuff in action, see how it works. So if you, and I did read it at night when I couldn't sleep. So if you want that link, and I'm happy to provide it to you after the fact, and you can go read it. So what is accelerated database recovery? It's a way that provides enhanced database availability, and this is the Microsoft marketing verbs or verbiage, provides enhanced database availability in the presence of a long-running transaction It allows for a faster and more consistent database recovery, which not only speeds up our recovery, but also helps speed up our application times, and does provide for almost instantaneous transaction rollback. True story, I have a client that is 100% in Azure SQL database. They had me, and they don't have a DBA, so I am their DBA. And they had sent me a query to modify X number of rows. It was a decent row count of what they're going to do. But they're like, this DML statement should be quick, shouldn't be a problem. And I run it, and I'm timing it. I got my watch, and I'm kind of watching, and 10 minutes goes by, and I'm like, this is not as quick as what they think. And then 20 minutes goes by, and then 30 minutes goes by, and we were modifying data on a relatively important table. And so after 30 minutes, I canceled it, and expecting, not realizing that at that point in time that accelerated database recovery was already enabled in Azure SQL database. This was a year and a half or so ago, and it rolled back in probably half a second, no more than a second. So a 30-minute long running transaction. And everything I did in their environment was in a transaction to make sure that I could account for row counts and that, things were completed successfully. And if they weren't, I could, effectively undo that change with rolling back that transaction. So when I killed it, it rolled back in a second, and it was really cool to see in production. The other thing that accelerated database recovery facilitates is really good aggressive log truncation. We've probably all been in that environment where we've got this long running transaction, and then the log can't truncate, and so it continues to grow and grow and grow, and then we run into a disk space issue. And so ADR not only facilitates a faster recovery time, it also allows for a very aggressive log truncation mechanism so that we can help curtail that excessive log growth. And this is another beautiful feature that I love about it. It's available in standard. You don't have to pay the extra money for enterprise to get this. You have to be in 2019, but you can get it in standard edition. It's the default in Azure SQL Database and managed instance already. So if you are running in Azure SQL Database or MI, you've already got this enabled. And actually, you can't even disable it in those two platforms. If you try, SQL Server is going to tell you pretty much to pound sand. Disabling that isn't even an option for your databases on the platform as a service service tier. So it works really cool. What's the Microsoft's official guidance on using accelerated database recovery? If you have workloads with long-running transactions, you should think about enabling it. Hopefully you're in 2019 or going to 2019. This is actually one of the features of 2019 or 2022 that I tell my customers, hey, if your applications are notorious for generating these long-running transactions, this is one reason to upgrade and migrate to a newer version of SQL Server, is to enable this one feature. We've all, as data professionals, we've always been taught, hey, let's minimize our transactions to help minimize the log growth and to facilitate better log truncation. And we should continue to do that, but sometimes we can't get around that. And so we still have workloads that have these long running transactions. If you have active transactions that are causing log growth to grow significantly, and or you've run into long recovery, meaning that you've had to roll back, or even crash recovery. You've had a failover and crash recovery takes forever to go through. Accelerated database recovery helps facilitate that process as well. Thankfully, it's not just with a running transaction, but when SQL Server reboots or has to go through crash recovery, it uses the ADR features as well to help speed that up. So if you have a very large database and you have a very volatile system, meaning it's super busy, ADR can help you reboot the server. I know that I've heard of horror stories of a reboot taking minutes because of that crash recovery, multiple minutes, because that crash recovery has to plow through the log file. So I feel like I'm going really fast. So we got some new components with ADR. And a couple of them are really cool. Some of them we can see, some of them we can't. So first up, we have the slog. So this is a new in-memory component that that SQL Server uses to help facilitate this new feature, and we'll talk about it. There's a new persisted version store. There's a logical revert, and this is the logical revert is kind of where all the magic happens. At least that's the starting point of all the magic. We have an aborted transaction map, and we have a new cleaner. And we'll go through all of these components and we'll talk about it. The demos we'll look at the version store, we'll look at the logical revert, we'll kind of look at the aborted transaction map. Unfortunately, with the slog, it is in memory, so we can't actually see it. It's actually a hash table that we can't see. So it is in memory. So, and I will note that ADR does add a little bit of overhead enabling it, just because of the way that it functions and the way that it does the slog and all the other components. But the overhead should be relatively minimal. And I think at the very end, I do have a slide about where we talk about, hey, this is where you should not enable ADR. So the slog, it does contain in-memory objects. It contains basically non-versioned operations. So this does not contain anything like a DML statement where we're doing updates or deletes. Those are all versioned. This would be something like we're going to alter the database and change a database component. That's a non-versioned operation. It does have a checkpoint. So those checkpoints are persisted to disk. Even though it's in memory, those checkpoints still have to be durable and persisted to disk. And really, the slog is what allows ADR to provide the aggressive log truncation. And I got a slide coming up that has a picture of how it all, like the sequence of what it works. And we can see where that log truncation happens. With the persisted version store, it's the same version store when you use read committed snapshot isolation. If you're not familiar with read committed snapshot isolation or RCSI, what happens is when you enable that, any committed version of the data actually gets stored. Let me rephrase that. It gets tagged with a 14 byte pointer on the row. That 14 point or page, I'm sorry, gets stored in the version store, which is in tempdb. And so when a transaction or a read statement comes in, you have RCSI enabled, it says, oh, I've got a copy of that data in tempdb. I'm going to go read it from tempdb instead of my user database. RCSI essentially allows for writers to not block readers and readers to not block writers. So that version store, you enable RCSI, you do get some additional growth out of tempdb because now we're storing more data in there. With ADR, because they modified the way that the transaction log works, they actually took a copy of the version store out of tempdb and slammed it into the user database. So when you enable it, you get new metadata around the version store that gets stored within the database itself. This allows for a couple different things. One, it retains the off-row versions, and we'll actually see those off-row versions. And so and I mentioned the logical revert, and I'll get to that in a second. The magic happens with the logical revert because what happens is when the data gets modified, if that modification can fit in row, it remains on the data page of that data. If the versions have exceeded the size of the row, then it gets stored in the version store on an off-row page elsewhere. And there's a pointer that links the two together. And we can actually see all that. The version store is also availability group aware. And this is what helps facilitate the crash recovery. So if you have a database that is ADR enabled and you have it in an availability group, because the version store is no longer in tempdb and stored in the physical user database, in that availability group, any writes to that version store gets transmitted with that same log block over to your secondaries. And so if you fail over, that secondary can then go through crash recovery and use the version store to identify what versions are correct and which ones aren't, and bring the database online very, very quickly, or at least faster. So the version store is AG aware, which is fantastic. The logical revert, again, this is where the magic happens. I really should have like some fairy dust or sparklies on this slide. It's asynchronous in nature. So which kind of makes sense, right? Because if you have a very volatile system and you're making a bunch of changes all at once, trying to revert this logically synchronously would just be a bottleneck. And so doing this in an asynchronous nature totally makes sense to me. And as I mentioned, this is what facilitates the undo at the row level. And so when we get to the demo, we'll look at that. I'll make some changes. We'll actually go look at the data page, and you can actually see those versions in the row on those pages. And then when we roll back, they'll be gone. Logical revert keeps track of all the aborted transactions. And then the beauty about ADR is, and part of the problem with the current methodology, meaning a database that is not ADR enabled, is that rollback time retains all the locks. And so if there are locks that are taken to modify that data, those locks remain in place until the rollback is done. Once the rollback is done, then those locks are released, and that's what allows you to get back into that table or tables to redo the transaction or fix whatever you needed to fix. With ADR, and this is what allows the ADR rollback to be almost instantaneously, is that the locks are immediately released as soon as you say rollback. Those locks are released. That logical revert will start to kick in asynchronously and start to roll everything back, and then you can continue on. So releasing those locks is what allows you to get back into the system very, very quickly. Excuse me. The aborted transaction map, it's not the ATM that you see before you, but it's not that ATM. So there's actually a very, very similar to the internal pages of a database, right? You've got a SGAM and a GAM, global allocation map. You've got a differential map that maps different transactions. A differential map keeps track of all the pages that have changed between backups. This tracks all the aborted transactions. We can't actually, I haven't found this one yet. I haven't actually found the aborted transaction map. I'm still looking, but I haven't found it. And that's because it's implemented as a hash table. I've actually poked around some in the debugger to see if I could find the aborted transaction map in the memory registers. I haven't yet. So I'm still looking, like I said. And the rows in the transaction map are linked to the rows in the persisted version store and or the rows on the page itself. The cleaner, and that's the dude from Scrubs. He's the janitor. I always thought I liked his character. It is asynchronous in nature. The downside in 2019 is that it's single-threaded for all databases. In 2022, I believe that they have changed that to be more multi-threaded. So the part of the problem right now is if you have a super volatile system, the cleaner can't keep up. If you've ever experienced or run into a ghost record cleanup process issue where you've deleted high volumes of data and then you run into contention because the ghost record cleanup can't keep up, you can run into the same kind of concept there, where you modify a bunch of data and then you roll things back. That cleaner process can't come back around fast enough to clean it up because it's one thread for all the databases, especially if you have a higher volume of databases on an instance that compounds the issue. So the cleaner is single-threaded. It essentially removes all the versions that aren't needed, and that's what the cleaner does. So it comes around and says, hey, that version is no longer needed. It's been aborted. See ya. Bye-bye. That's what it does. You can't disable it, but you can run a manual cleanup if you want. If you force that cleanup is synchronous. And it does come with some configurations. So if you have a database that is ADR enabled, you can actually look, that's at the system level. Sys.configurations, configurations, there are two new configurations that you'll see. ADR cleaner retry timeout and an ADR pre-allocation factor. Now the retry, that is basically, if the cleaner runs into an issue while trying to get a hold of a lock in order to clean out the versions, it might die. And so if it dies, then it will retry. And essentially there's a default of 15 seconds where the cleaner is going to retry again in 15 seconds and spin back up. The pre-allocation factor. This is related to the version store, the persisted, the PVS, the persisted version store, in terms of how the pages are pre-allocated for the version store, because just like you might have run into contention with TempDB with allocating pages for your data, right? And the solution to that is to add more data files for TempDB. If the version store can't allocate pages fast enough, then you could run into contention. Now, I can't remember why I put an asterisk by here. My notes say use this with caution. So like most things with SQL Server, just because you can change something you probably shouldn't, I have yet to run into a problem or a scenario where I was thinking about changing either one of those two settings. So I probably would not change the retry timeout or the pre-allocation factor unless Microsoft support told me to, or somebody who's smarter than I am said, hey, yeah, there's your problem. So I would not change those two, but it's always good to know that you've got some configuration options with ADR evenly. How do you enable ADR? It does require exclusive access to the database. So it is a simple alter database name, blah, 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 set accelerated database on, accelerated database recovery on. And you can specify a different file group. So if you have a database that has multiple file groups, if you wanted to, you could put things with ADR related into a different file group. So if you so desire, you can do that. Okay, any questions so far? Don't think so. Okay, am I going too fast? Ooh. Old school versus new hotness, new school. You've probably all seen this. So this is the old way. So this is a database that does not have ADR enabled. And the first thing that it's going to do is, if you have a long-running transaction and you kill that transaction and it rolls back, the first thing it's going to do is phase one. It's going to do analysis from the last checkpoint to the end of the log. So if you have your last checkpoint is a while ago and your log's pretty big, that analysis normally is pretty quick, depending on your disk and all that stuff. Once it's done that analysis, then it's going to do a phase two, and it's going to go all the way back to the oldest uncommitted transaction and essentially replay all those transactions. And it's going to replay those transactions until it gets to the end of the log. And then it's going to turn back around and go back the other direction in phase three and basically do the undo. So any transaction that is not committed gets redone or undone, excuse me. And so this picture kind of really illustrates why that rollback process takes forever. If you've got a transaction that's running for 24 hours, it's got to plow through 24 hours of redo and then undo everything. With ADR, I'm sorry, there was actually animation there that I had that I didn't realize. Without ADR, and as I mentioned this before, the rollback is usually proportional to the longest running transaction, right? So if you've got a transaction that's running for 24 hours, you kill it, that's going to take 24 hours to roll back, usually within limits. It never fails. There's always some C-level person standing behind you wanting to know how long it's going to take to recover. I don't know. With ADR, they've changed this, and this is where we see that the different components kind of come into play here. So we still do this phase one analysis. That step is identical. It uses the last checkpoint and it goes to the end of the log. But that's the only part that gets scanned. Then what they do is we actually do a two-part phase two. We actually redo all those non-versioned operations from the S-log. Remember, that's an in-memory object. And so in memory, it's very quick. We don't have to rely on the disk subsystem to give us that information. We can get it straight from memory. We redo the S-log components, and then we redo from the last checkpoint to the end of the log. So we're no longer doing the redo from the oldest committed transaction. We're doing the redo from the last checkpoint. And as long as you haven't messed with your checkpoint settings, it should be, I think the new default is 60 seconds. So that too should be very quick. And because we're only doing that redo from that last checkpoint, then we can just undo everything else from the S log. So it just turns around and does from the end of the log all the way back to the oldest committed transaction, but it's only the S log. And the S log is, because the S log only contains non-versioned operations, the number of operations in the S log is very, very minimal. It's not a lot. And so that operation, that phase 3 operation, is pretty quick. And so that S log is super important. And that's what really facilitates that faster redo. So with that, I just threw a bunch of information at you. Any questions before I go blow up a SQL Server?
I've got a question. Is there a rule of thumb you've found useful for sizing that PVS file group?
I have not. I actually don't have anything that indicates that I should even put that into a different file group. I normally just put it in the primary and leave it. I've never had anybody ask me that question, so that's a good question. So I don't know the answer to that. I'm sorry.
No, that's helpful. The fact that you say you usually put it in primary is helpful to me because I haven't used this feature yet. So thank you.
And if we look at Azure, like Azure SQL Database and MIs, at least with Azure SQL Database, you're not going to have multiple file groups, I don't believe. And so I would assume that it's enabled on the primary. So I think enabling it, putting it into its own file group, I think would be more of an edge case scenario. I'm seeing a lot more customers and clients that aren't doing that splitting out of the file groups anymore, just because like storage and memory are so much faster in CPU. So good question though. So this is in big, bold red letters. My demo, we do have a debugger. Please, please, please don't attach a debugger to your production SQL instance to play around with it. I actually blew up my SQL instance last night because I clicked the wrong button, and I actually had to go fix SQL and then restart the services because it completely trashed it. So with that, let's go blow some stuff up. You should see my management studio. I will tell you that my management studio is on my other monitor, so I'm going to turn just a little bit to my right. My right, your left, probably. It's not that I'm not looking at you when I'm talking to you, it's that I'm talking to the monitor. And so what I've got here is a SQL 2019 VM in Azure. It actually updated itself last night to a more recent CU. I think it's one CU behind the security CU that 2019 released earlier. I've got a couple databases out here. The ones that we will probably play with the most with is the ADR one. And the first thing that I'm going to do, I normally would show you like a long running transaction, let it run for like 7-8 minutes and then roll it back. The problem I had was trying to get the disk to be slow enough to actually like be worthwhile was kind of getting to be a pain. And we've probably all seen this, so I'm not going to do it this go around. But what we are going to look at is one of the cool things that I think is neat with ADR is that we can actually see how the transaction log behaves depending on what's enabled. So if I go to this, I'm going to alter the ADR database. Let me back up. In the ADR database, I have a very simple table, a people's table with 3 columns, an ID, a first name, and a last name. Right now, this table should have just a single row. They always say don't type in a demo. Should have a single row. Oh. I'm in it somewhere. Ta-da. This is why they say don't type in a demo. Yep, I'm in it. Let's see if I can get rid of it. Yep. See. See here, I thought I had all the demos all squared away. Yay. Okay. All right. So I've got one row, my first name, my last name. And I'm happy to share the scripts. If you guys, if the group wants the scripts, I'm happy to share it. I'm going to make sure that ADR is not enabled. So we're going to look at the log file and see how it behaves without ADR enabled. Let's use ADR. I want to look and see. Okay. And this will come back into play. I just want to see how many pages are allocated to the people's table right now. And here we can see, and this all makes sense. We have an index allocation map, and then we have a data page, and we've got 7 other pages. So we have 8 data pages in total, which makes total sense because in newer versions of SQL, they've turned off the mixed allocation. And so right now, anytime I create a new table or add data, it's going to allocate 8 pages at a time. And they're all going to be in the same allocation map. So there's a GAM, not an SGAM. Makes sense. We talked about the persisted version store. I can actually look and see inside the version store. I can look at the size. And so you could, back to your question about doing your own allocation, or I'm sorry, your own file group. What you could maybe do is do some testing in your non-production environments and see how this grows and how it handles, and then adjust accordingly. So you can actually see that size of that persisted version store. Okay, so I'm going to run a couple checkpoints, and basically what the checkpoint does is going to flush everything from the cache down to the log file, allow the log file to be as clean as possible. We can actually look and see. I'm going to look at the log file. So if you've never looked at the log file, if you use this function fn_db log with null, you can actually see the log operations that are currently running through your transaction log. And you can actually look up what these operations do, what the context is. You can actually see quite a bit of information within the log. When we actually change data, you can start to get file ID, page ID. You can actually start getting who made what, who did what. But so if I begin a transaction, I'm going to update some rows. And Duke is my father. I lost him last year to COVID. Pete is my dad's father, my uncle, who I also lost last year to COVID in 2021. So I'm immortalizing them here in my demos. So that's who Duke and Pete are. So Duke's my dad and Pete is my uncle. So if I update the value to that one row, essentially I'm changing the value from John to Duke and then from Duke to Pete. And then I'm going to roll everything back. If we look at the log file, there's a couple of different things that we see. One, we can see I call it loop. It might be lop. I don't know. A lop begin transaction. That's what the exact ACT is that's the start to my transaction. And here's like my transaction ID, and we can see all this stuff. Here we can see that I've modified some rows, and then I did my rollback. So I modified 2 rows. I'm sorry, I modified the row twice. And then I said, hey, I'm going to roll that back. And because those were contained in 2 separate update statements, I've got 2 separate compensation records. If you come back out here, you can actually see there's a compensation record. These compensation records is what actually tells SQL Server, here's how you undo that change. Here's how we flip it back from Pete to Duke, from Duke to John. So that's what the compensation record is. At the end, we can actually see this abort exact means that the transaction has been aborted. And at this point in time, that's where all the locks on that table get released. So that's part of the problem, as I mentioned before, in the current or the traditional rollback mechanism. That's what takes that rollback so long, is that we have to wait for all the compensation records to take place, and then the locks will be released. So if we change this to say, let's enable ADR, let's see what happens in the log file. I'm going to do a checkpoint just to make sure that the log file is clean. I'm going to run it twice. Yep. So we can see here that we're back to normal. There's no other DML statements going on. Just your normal checkpoint process, and it's ready to. I'm going to run this. And so I ran into this yesterday. You'll see the comment there that says run as a block, because the cleaner, when I was verifying the demos and making changes, the log file would get really, really cluttered because the cleaner was coming in behind me as I was committing, rolling back, making modifications. And so the cleaner was coming back faster than I could get to the log file to actually look at the contents in a usable feature or usable way. And so that's one thing that I ran into with the cleaner. So I'm going to do the same thing. I'm going to do some checkpoints, begin a transaction, update the exact same row to the exact same values, Duke and Pete. So I'm going to go from John to Duke to Pete. I'm going to roll it back, and then I'm going to look at the log file. See, even then, I didn't catch it. See all the stuff that's in here with the version store? Part of that is the cleaner. Let's see if I can run that again. It's way too messy. Oh, that's even worse. Did I not do the checkpoint? Let's try this. Could be because I did 2 rows. Let's do it this way. This will work. I can make this work. So we still have a compensation record there, right? So SQL Server still has to have that compensation record to know where to make the changes back to. But if we look, our operation order has shifted. We still have your begin transaction. We still have your modify. So this is the initial update statement of where I changed the first name from John to Duke. So I've modified my row. Then we have this new thing right here. Lop forget exact. It's actually not new, but we see it in the new order. And what this does is this is where the locks get released. And so what that is telling SQL Server is saying, hey, forget the transaction. We're going to abort it, release everything. Once it's released, we can get back in the system, right? So we can start doing data modifications and move on. Behind the scenes, SQL Server is going to come back around and actually modify my row back, because this is the row, if you remember, I can't scroll over, but row 7 was the one that had the compensation. And then once it's done the compensation, my transaction's done, we're aborted, we're out, right? And so we can actually see how the log behaves differently now with accelerated database recovery enabled. Any questions about that? Cool. Awesome. All right. Now we kind of get into the fun stuff that I like. So we still have ADR. We're going to use the exact same database. I'm going to set it to on just to make sure. And it's not going to because I've got a transaction open. I'm in a different database. Cool. Da-da-da. Execute some checkpoints just because. So it also, back up. I'm going to back up here. We looked at the page allocations, and I think it's the same page ID. It allocated a bunch of stuff. Why did it allocate a bunch of stuff? I'm pretty sure I got the right page ID. Let's check. I did. Okay, cool. So I want to make sure I had the right page ID. So I'm going to do the same thing. I'm going to execute a transaction. I'm going to change the first name from John to Duke, right? And then I'm going to look at the data page. So this is, you set the trace on 3604, returns the contents of the data page back to the console instead of the log file. I know in advance that it was page 336 that I needed to look at. And so if I look at that data page, we see a couple different things. And if you're unfamiliar with what a data page looks like actually the hexadecimal and the bits and bytes on disk. This is kind of what it looks like. And there's a couple of things that I'm going to point out here. One, we see actually some new information right here where SQL Server on the page has now said, hey, ADR is enabled. And so on this page, because we're changing data on the page, I have to keep track of some version information. And so if ADR is disabled and you go look at the data page, that versioning information text is not there. It won't be there. When you enable ADR, then it'll start to see there. This is the hexadecimal for the data on the page. The offsets tell SQL Server where on the disk that data starts. All this information up here is about the page header, what kind of page it is, what kind of record is it, how many null columns do we have, how many bar chart or variable width columns we have, how many fixed width columns do we have. But what's really cool, and I find this, I think it's fascinating, you can see that the value of the first and last name is Duke Morehouse, right? And so we've made the change from John to Duke. We can see Duke is on the page, but if we look a little further down, you can actually see that John is still on the page. So remember I mentioned that if the value of the version is small enough, it'll actually store the value of that previous change on the page itself. And so it doesn't have to go anywhere. It doesn't go to the version store. It doesn't go anywhere else. It's stored right there on that 8K page. Now, a couple of other things that we notice down here is, if I come back out, not only did this version information show up, we also have this little tidbit of information that has now appeared. And again, if you do this with ADR disabled, you're not going to see this information. So this information is what tracks the version store as well as other version information. And this information is actually stored in the bits and bytes right here. And so we can see page ID 1. This is byte reversed. And so this really is 0001. So that's my page ID. If we have a hexadecimal editor, and lo and behold, I do. If I take this byte, which is, and again, byte reversed. So if I take 0302, which is 302, $770. Do we see a 770? Oh, look, it's the file ID. So we know now that this byte is the file ID, 770. If we take this FCFF, and again, it's byte reversed. And so that's because of big endians and little endians. And so if we byte reverse that and go back to our hex editor, so now the FCFF actually becomes a Foxtrot, Foxtrot, Charlie. If we convert that, because SQL Server does work on a 2's complement, we actually get a -4. Do we see a -4? We do. So there's my current slot ID. Now it's a current slot ID because it's in row. It's in the page itself, right? And then if we take this byte, which is 6004, I can't remember. I think that's byte reversed. So if I do 0406, I was wrong. 0604. Or NA.
Should be 60, I think.
60. Hang on. I had that figured out. Just a second. Yeah, see, like before, here's my example. This last bit is, I'm sorry, this last byte is this transaction timestamp. And we can actually track this transaction timestamp back to the version store. I'm not sure why that is, because if I do 049 alpha, come on. 049 alpha. See, my demo yesterday when I was messing with it, that was the appropriate timestamp. So I would have to look at that and figure that out. I can't do it in my head. I know like Paul Randall can do it. What was that?
It's there. It's the same. It's the part you have highlighted bit reversed like it was before. So it's 460.
Oh, come on. This is why they say don't type in a demo, right?
Yeah. No, it's the other way. It's 460.
Yeah. Okay. So 0460. Yeah, because I swapped them wrong. That's why. Because I was an idiot there. So we can see now, thank you for that, by the way. We can see that all this information is actually stored in the hexadecimal right there on the page. So now if we look at the version store, because we know that that value is on the page, I'm going to go look at the version store. And the version store DMV will tell us a couple different things. One, I've got one record count. I've got one versioned record, which is true. I've got one, John is that version record. I have one in row, one different version, my payload, and I have 0 off row versions, meaning I haven't exceeded the data capacity of the row yet to actually throw a versioned value into the version store. Okay. So let's fix that. And we don't see anything like if we look in the version store. This is all old stuff. But if I come back around and say, hey, all right, I'm in the same transaction. Keep in mind, I haven't rolled anything back. I haven't committed anything. I'm going to update the value from Duke to Pete. We're going to look at the same page again. So I still have this versioning information, but we can see that my actual information, now all I see is Pete Morehouse. The values of Duke and John are gone. They've gone somewhere. We still have our same bits and bytes, right? And so the file ID, the page ID, and the timestamp, they're all, you can see it right there. There's my timestamp. It's all there, but my slot ID has changed. This is the slot ID, so 0001. My slot ID has changed. So, okay, if my slot ID has changed and my previous versions aren't in row, they have to be in the version store. So we can actually go look at it. And now we actually see, I still have my version count, but my off-row counts have now disappeared because I've actually moved that version of data out of the data page itself and it's into the version store. So now I've got one version row count in the actual version store. And if we look here, remember that timestamp? That timestamp was 1120. So we can actually correlate the version store to that timestamp on the data page of that TS push. And so we actually have information in the version store that kind of ties us all together, right? And so that makes sense with how the version store now has to interoperate with the data page to figure out where those versions are kept. And so that's a transaction timestamp, right? TS, transaction timestamp. And the versions are contained within the row versions of this row version column. Now, I want to do a quick test. Let's see. I don't think I tested this. Oh, what did I just do? And I have they always say, don't type in. Oh, not there, John. Bear with me. The only reason I'm doing this is because I just converted some binary. Nope. Okay, so you can't actually convert that. Nope. At least not easily. Yeah. Quick, small experiment. So now I'm going to roll that back. Cool. So now we saw the version store in action. We saw the in-row and off-row versions of that. So what else can we do with the version store? What else can we find? We can actually use extended events. And so we actually have an extended events. I set one up. That's what this looks like. And I can actually, actually extended events trackers that fire whenever the version store gets modified. So if we insert new records into the version store, we can actually capture that within extended events. So if I go back to my query, and I'm going to actually look at the extended events, and we can see it right here. I probably have some data running. I do. Let's see if I can clear it. Okay. So I'm going to clear it just so I have a clean slate to start with and play with. I'm going to start a transaction. I'm going to update some rows. If we come back and look at our extended events, we now have data. So we can actually see that, yep, the extended events session has fired. And so we've got some trace data and information. We can actually look and see, if we look down here, a couple different things. One, we get a call stack. That's what this is right here. We get the database ID, all that good stuff, database name, our actual statements. We actually can see that we have, the first one was the PBS in-row. We generated some in-row versions, 24 bytes. Here's our timestamps, 1121, which makes sense because the previous one was 1120. And so we get some information out of this initial one. If we look at the second one, this is the one that I thought was really interesting. Because the persisted version store is a physical table within the database, it has to have a page ID. So we can actually now see, hey, where did my versioned records go? Where do they live? And so now we can actually see that we have file ID 1, page 352. We can actually go look at 352 to see what's actually on it. And so we can see our statement, right? We've updated the table, Duke, and then updated it again to Pete. We know that we used Schedule 6. And so if we had take 352, and run this, you see, yep. So we have a valid page. It does belong to the persisted version store. It does have a valid page ID, which, if you've ever noticed, I love this naming convention, allocated page ID. And it has an associated index allocation map. So it kind of follows the same suit as a normal transactional user data page. We have a allocated index allocation map for those persisted version stores. Okay, so does that mean we can go look at it? You betcha. 352. Whoops, my dyslexia was showing up there. Ta-da. So this is the page that actually has the different values for that persisted version store. So we can actually see those pages and go look at it and know that it's happening. This is one of the reasons why that if you enable ADR, if you have a very busy system, you may see an increase in overall database size because we have to now keep track of those 8K pages to store the persisted version store. So I haven't seen a ton of overhead from that perspective, but it's something to keep in mind. If you have a very large database, and multiple terabytes is what I'm thinking, you could see a not a decent, I wasn't thinking like huge, but you may see an uptick in database size because you're changing so much data, you've got to keep track of all that. So you've got more additional 8K pages to keep track of. And then we can roll it back. So cool. We've seen the version store operate. We know that we can go fetch and find the pages where the versions actually live and how they all interact together. It kind of all makes sense now. But I was like, well, okay, so can we go even further? Can we actually see in the code where SQL Server does all this work? And the answer is yes. Because I had extended events running, I mentioned that we can actually see the call stacks. So we can actually get a call stack. So I can actually copy this. And I learned some stuff when I started to work on this and try to figure this out, because I love doing the internals. I like figuring out how SQL Server works from an internal perspective. I found out there's some really cool tools that exist in SQL Server community that I didn't know about. One, there's a SQL call stack resolver. It's a free tool. You can see the aka.ms/SQL stack link there at the top. You can download it. It is free. There's a GitHub repo for it. But if I take this call stack, make sure I copied that column right. Highlight it in here. That didn't work because I need to. Let's see if this works. Okay. Oh, did it die? No, come on. There we go. In this call stack resolver, I can put a call stack out here. Actually, you know what? That's why because I needed to do it this way. If you run this query, we can actually get the call stack from here. I did that backwards. Now I've got the call stack in the right order, so I can actually undo this checkbox. So in this call stack, like this is all gibberish to us. This is just indicating which DLL is being called for that operation, but it doesn't really tell us anything. But we can put the call stack in there, and if we say use public symbols, we can actually go find the public symbols for a given version of SQL. Now, it is very specific to which build are you physically on. And so because I'm on build 4236, we can go to RTM 4236, right? And so I said that I was 1 CU behind. And then I can say download public symbols. And unfortunately, we can get the public symbols. We can't get the private symbols. So this is about as deep of a level that we can go from a debugger perspective. But once we pick the right symbol package, we can say resolve the call stack. And so the call stack resolver is going to compare the call stack that I pasted with what the public symbols are, and then actually return us a little bit more verbose information. So we can actually see here, oh, we've got now have some persisted version store modules where it is doing various things with the version store. Well, okay. So can we kind of see when that happens? Why, yes. Yes, we can. So again, free tool. And again, if you like internals and want to like blow things up, this is a cool tool to play around with. Now we know we have some modules that we can go play with. The persisted version store manager. And so we can actually debug SQL. And so I've got the debugger running here. It's been running this entire time. We can actually break into SQL Server. So right now, and again, don't do this on a production box or any box that you deem valuable unless you can recover from it somehow. I've broken into the assemblies. Right. And so like right now, I can't do anything with SQL. If I try to do something, it's going to sit there and hang even with a simple use statement, because right now the application is stopped, it's dead until I say go. The debuggy is now running. And so now SQL Server, if I go back, this will complete. And so this is actually stopped. So I'm going to break back into it. I think I had in my script, put it out there. Yep, this right here. So this is the one that I wanted to look at. I can set a breakpoint. And the breakpoint, if you've ever done C# development or pretty much any types of development, you know, a breakpoint allows for the application to actually stop when you hit that particular module or method or call. And so we can do that with SQL Server. If we break in here, did I not copy it? I'm going to copy it again. So right now, SQL Server is not running. There it is. And so the BP says set a breakpoint. I'm going to set it for the SQL min bang version manager add record to PVS. So if I add that, it's busy, it's thinking. So it's added this breakpoint so that whenever SQL Server, whenever the C++ code calls that particular method, it's going to break. So I'm going to hit go again. And so my debug E is running again. So SQL Server is running again. So let's try that again. So I'm going to start a transaction. Let's make sure that this is actually rolled back. Yeah, okay, cool. I'm going to start another transaction. I'm going to update one row. Now, that finished. Why did that finish? Anybody? It finished because I haven't hit the version store. Because that changing this value is still in row, it's still on the same data page. So I haven't made any modifications to force it to the off-row storage. So I'm not even touching the persisted version store yet. Because I'm not touching the persisted version store, there's nothing here for SQL Server to break out of. Now, if I come over and update Duke to Pete, you'll notice that this will sit here and hang because this actually has now broken out because we've hit that specific method. And so if anybody has ever done any type of, I took assembly when I was in college because my physics professor made us take assembly. I don't remember why, but I definitively remember taking assembly. You can actually now start to see, we actually see some assembly-like calls where we're going to move and push and pop memory registers around. I have yet to figure out what the correlations of all this information is, but we can actually start to look at the various memory registers and see data moving around. So if you're really bored at night, you're welcome to go through the memory registers and start like looking through them to figure out where this data is moving. I haven't gotten that far yet. I just thought it was cool that we can actually see where SQL Server actually calls that method. And then we can actually step into it as it's moving data around. So right now, all we're doing is moving data into the persisted version store until it's done. It actually does quite a bit. So we can actually see that movie flow through the memory registers in the debugger if we really wanted to. Now, of course, I can just hit go. And voila, our row is done. It has been added to the version store. If we scroll back up. Yep, we see that we have one off-row version, which is what we expected. Roll that back. Okay. Any questions? Would you ever use this in production? Probably not, but that's how it works. No questions? Cool. All right, that was the end of the demo. So if you want to see anything, speak now, forever hold your peace.
I'm just sitting here with my mouth hanging open, watching you do all this stuff, and like how you just rattle off. This means this and that, and this is the other, and here it is. So sorry, I'm just amazed.
This was really fun for me to figure out how to make it work. And this is like some people don't care about how this works and whatnot. They just want it to work. But I'm that DBA that I'm like, I want to know how it works. Because for a long time, Joey and I just thought it was magic. Like literally just SQL Server had magic built in and it just magically worked. It's really fun.
No, I think you're right that we're not ever going to use this in production, but it's fascinating to understand how it works. And thank you for digging in and showing, the magic behind the scenes, because it is fascinating and interesting.
I wish, and good to hear your voice, good sir.
Thank you.
I wish that I actually had been pinging somebody within Microsoft to like take a look at this within the private symbols so that I could have some more information in terms of like, what does this method actually do? Like, I want to see the code behind it. Unfortunately, obviously we can't see it. But I keep hoping that somebody within Microsoft might like throw me some tidbits to add on to this, but I thought it was fun. Let's see if I can. Okay, so it is running, and this is where I screwed up yesterday. because I don't think I detached it when I ended this. And I don't remember where the hell to detach. It's there. Oops. Cool. Let's see if I blew up SQL. Oh, I did blow up SQL. Look at that. Yeah, it died. It died horribly. Oh yeah, it died. Look at that. It becomes online. Thankfully, I have backups. Am I in recovery? I'm in recovery. And I'm out. Cool. So yeah, debugger will blow stuff up even when you try to like exit cleanly. All right, so back to our slides. We're almost done, I promise. The robot. When
I love that. I love that.
That's, you'd be surprised that I've had people like being at my sessions and like, I'm gonna go try this in production. No, don't do that. Please don't do that.
It's not exactly a troubleshooting tool.
ADR. As I mentioned before, if you're highly transactional, ADR might not be a good scenario for you, especially in 2019 because you've got that single-threaded cleaner. With 2022, they've enhanced ADR. They've added multi-threading cleaners for it, so you might get better throughput with 2022. At this point, if you're thinking about going to 2019, I actually might wait until 2022 comes out because there's a whole another slew of things that are coming with 2022. If you are doing high volumes of data modifications, just like with highly transactional, most likely you're going to be in an edgy case scenario of not enabling ADR. I've got a client that is borderline that edge case. They've got a high volume of databases compared with the number of CPU cores on their virtual machines. And so I haven't actually implemented ADR yet because I'm concerned about the overhead from a CPU perspective causing problems. So I have not enabled it for them. But you can monitor, always test it. You can monitor the version store for issues. So you can see if it's growing exponentially or causing problems. You can then adjust as necessary. So there are a few edge cases where I wouldn't enable it, but 8 out of 10, 9 out of 10 times, I would enable it, test it, make sure it works or behaves as you expect, and then put it in production. And thankfully, it's an easy thing to fix. So if you have run into problems, as long as you can get a lock in the database and undo it, you can turn it off. So quick summary, ADR facilitates a faster rollback. As I mentioned, my client that I had to do that rollback for that data modification, it was really cool. After, you're chewing on your nails because you're like, oh, it's going to take 30 minutes to roll back. And then you click roll back and it rolls back in less than a second. You can crash recovery upon startup or failover. Again, if you have a large database, assuming that your redo queue on a secondary is caught up, you can restart and failover a lot faster. You get your aggressive log truncation. And so you get better management of your log file. With ADR enabled. Enable it for the majority of use cases, and it is simple to enable. Here's a couple of links. I mentioned that call stack resolver, which I didn't even know existed until I started to kind of like plow through some of this stuff. I've only found one good article about how the internals work in terms of like the logical revert and the all the components and how it works. And it's out on Redgate Simple Talk. There's a young gentleman who put it. He's got fabulous animations in his blog post. I don't even know how he did it, but that's a great article to read. And then the white paper is the link to, I believe, the original white paper that I posted at the start of the presentation. And with that, any questions, answers? You want me to go blow up SQL again? You want to see anything?
I'm going to go ahead and stop the recording.